Alright, hey guys, we're gonna do another Gnosis Python exercise, I guess, or walkthrough, whatever. Notice there's a request for Spiderman 3 PC, and I'm like, oh, it's like a movie type format, like movie type of game. So I'm like, the format must be easy. So actually, yeah, it ended up being easy. So whenever I do see like easy formats on here, I'll try to jump on them and do like a video on them and stuff like that. Something complex. This is like something that might take like a couple days to a week or maybe more than a week to kind of like really flesh out and write out properly just from limited time and all that stuff. And so it's nice to get like an easy format because they're easy to work on for people to try themselves. So it's great. Anyway, he posts some samples here of an archive. These guys have already cracked it, so Crocs posted up his solution. He's actually using Quick BMS for this, and he has a very simple extraction thing here. So we're going to transcode this into Python so we can use Noesis to extract the file. Now, is this more ideal? No, probably not. Quick BMS, why would you use that? Because you can batch export things. You can put it in a command line, just export a bunch of files. Gnosis, I'm not sure if you can do that or not, to be honest. But I was thinking if I was going to make a full modding suite, let's say I'm going to mod a video game, it makes sense to include an extraction and repack function with my suite. When I say suite, I may be pronouncing that wrong, but you know, I want a model importer, model exporter, file packager, and file unpacker. So this is part of my grand scheme, I guess, is to include this into a tool set, I guess is a proper word, I guess. So yes, Quick BMS probably more suitable for this type of thing, but I would say it is a cool little thing to actually include this with your tool set for Gnosis. It would be nice to have Gnosis as kind of a Swiss Army knife of things, so I mean, why not? Anyways, so I'm going to use this and a sample. We got an example here. This example shows or demonstrates how we can read a file, and I'll just modify that with my existing knowledge when I was doing my model importing using the Gnosis Python example text file, where it shows us how to import a model. So I'll use this as the, I guess like the basis of how I'm doing things, and I use this how to get the flow working, and I guess I'll just use this as the file extraction or the file structure, I guess, for us. Now the only thing I must mention about the Chris or Crocs's implementation that he posted, he says this already. He says there's only one file sample, so he can't really determine a lot of things. But what he does is he just subs in the file count as 152. If somebody tried to use that on a different file, it would probably crash or something. You actually have to go read the file count, which is not in here. So we'll have to modify that in our implementation to correct for that. Other than that, then this is going to work out perfectly. Down below, they go on about models and stuff. We're not going to get into that. Okay, we're just going to do file extraction. So, okay, so we're going to take this this thing here, and I'm just going to, well, yeah, I'll copy it. It's probably the easiest thing. Now I'm going to be using code blocks as my my coding environment for Python. It's free. It seems to work out all right. Okay, so we're going to go new file. When you go to empty file, make sure you save it first. This is what I found out. And you want to save it as your py file. So we're going to call this. I'm going to call this whatever format PC Spiderman 3. I guess we'll just leave it at that. Yeah, whatever. So you need to save it as a py. I'm not sure if you have to like close it and reopen it or not, but if you don't do that, it seems to make some glitches. So when I go like tab, it's there. It is again. It's wrong. So for some reason, this is 4 spaces instead of a tab. Don't know why it keeps doing that. I think you actually have to paste some stuff in here. Actually, save, then close it, and then reopen it. Open. Let's open it up as a Python file, maybe. Spiderman 3. Let's try this out now. Tab. This doesn't work. I don't know what's going on. Whatever. There's some settings up here, but they don't seem to be working correctly. Editor. I don't know. It seems like it's supposed to be right. Anyway. We're going to include this line. We're going to have this line basically on the top of all of our scripts. It's going to, well, it basically says from this script here, import everything. So there's a lot of functions in here, including the import module command for Noesis, struct, and wrappy, which are important. You need those to actually interface with Noesis, so you need those. And by importing that one script, you'll get all that stuff at one time. The second thing you need to have up in front is this thing, register Noesis types. This is in all the examples. So I believe Noesis looks for this one and only function, and then through this one, I'm like trying to get the file over here, and it's like banging on the side of my screen. I'm like, what are you doing? Trying to snap to my screen or something. Don't snap to my screen. Okay. So in this thing here, it's always the same. You just set up your handle, which is just you registering your file. So Spiderman 3, 2, 3, 3, 2 equals 3. Then you put the extension, which would be for us pcpack. That's what the file extension is, by the way, because you didn't know that. Anyway, and you put in whatever you want to put in there. So Noesis must be the module, and then you can access that module, and the commands or the functions from that module will activate certain things within Noesis. For example, this is going to activate the extractor, I guess. In the model examples, where are the model examples? Check type. Yeah, right here. I'm blind. Okay. These ones, you can load models, you can write models, so forth, so forth. So if you want to do other things, you can include those as well. The only other thing I would just include is this thing. So we won't include that because we're not doing that, but oh my god, stop. Windows 10, man, tell ya. Noesis log pop-up. That will cause a pop-up. Oh. This thing, this pop-up will pop up. So it's really annoying because it'll check every single Python script. If it sees this even once, it'll pop up. So it keeps popping up for me now because I forgot to unskip it somewhere. So once you're done with this, make sure you put a pound sign in front of it and just skip it because it is really annoying. Yeah. Anyways, let me get rid of the rest of these plus signs. I don't really know why those are there. We don't want those. Okay, so we're going to leave that skipped for now, but it would be unskipped for you when you want to do your printing and debugging and stuff like that. Anyways, so we're using this one, set handler, to extract an archive. We give it the handle, which is Spiderman, and then we give it the function that we're going to be using to do that work for us. So it's going to execute this thing. It seems that we're given these 3 arguments, so you I think you have to kind of have them there. In the other functions for model importing, it kind of works the same way. Like for Noesis check type, you're given data. For load model, you have data and model list. Model list, as you modify it, will send things to the screen. So it is important, actually. Stop snapping! Oh my god. Okay. So file name will be just the file name, as just the file name. File length will be integer value of how long the file is. Just checking seems to be a little bit special, I guess. I don't know exactly how this is working, but if I delete this line, then I cannot, or actually that's the word, what's the proper word? when I click on a file, Noesis will try to preview that. And if this is an extraction function, when I click on a file, it will try to preview by trying to extract the file as I'm just navigating. That's really weird. So you have to include this thing. So when you click on a file and it tries to preview it, it realizes, oh, okay, we're not going to run the rest of this function, and it doesn't completely extract something. So this is really bizarre, but this has to be here. Now I believe you can implement this like this as a single line. Once it finds the new line, it'll just, yeah. So you can just leave it as a single line to kind of minimize that. It's really annoying. And this actually, I would say you want this at the very beginning of your function, because you don't really want to do any other work if it's not gonna, if you don't want it to preview something or run it after the preview, I guess. So after this is just kind of for this other format that the example was for. The only thing you need to take out of that is this thing, the wrappy command there. We'll put that right here for now. And we'll just get rid of this stuff, with the exception of this line right here. Now, in the other examples, we were actually using the Noesis Bitstream right here. Okay, I'm going to try and use that in this example. I don't know if that's a good thing or a bad thing, but it keeps consistency when I'm showing how to read values. Otherwise, we have to read values in Python natively, the way Python would read it. And that might cause some confliction for newcomers on how to do it. So I don't know if I'm doing a bad thing right now or a good thing right now, but we'll stay consistent with the previous video I made when we followed this example. Okay. So we will be using the Noesis Bitstream again, that class, which is this thing, which is detailed in, well, not detailed, but it's in here. This is the Noesis Bitstream, and you can see the different functions you have in that class, like reading and writing and seeking. I think that's a little more easier for people to like look and oh, okay, this is what I can use for them. Okay, so that's in your included script. So to implement that correctly, you actually have to put this together with the Noesis Bitstream. So that was kind of a challenge, but anyway, the way I figured this out is you use this command with your file opened in a RB mode. RB mode means to read binary as F. So F is your open file in this bracket, I guess, whatever this is. Okay, so that means in your indent, so you put some stuff here and you close the indentation, whatever's in here, F would only exist, and then it would close out of the indentation after, or it would get cleaned up. So we can also do a single line implementation just by going after the, what do you call those, the two dots. We can just do the normal thing. So in his thing, it would just go like this. And then data would actually be f.read. Read is a native Python thing. We're going to read the entire file, so that would be the file length, like this. Okay. Now I don't like using BS as the file stream, so I'm going to switch this around. So BS will become F, and then the Fs that were there before will become BS. So BS will be the entire file, and then F will be my Noesis Bitstream. Okay. There we go. So we've got single line file check, and then we have single line. This is all messed up. Single line file open. Okay, so a little bit messy, but it will get us on the same playing field as we were dealing with when we were doing the model stuff. And now it's really easy. We're just going to transcode what Croc's posted up about the file, and that's still fairly easy. I keep doing that. I don't know why my indentations are so screwed up, but they are super screwed up. Sorry, I'm just going to fix this real quick. What's going on? Okay, so start from the top here. So go to means to seek to an address. Now, to do that, we'll be using the Noesis Bitstream, so you can check that out, of course. We can use the seek, so f.seek. So f is our class function, the Noesis Bitstream. So we go f.seek, and in brackets we would go with the address. And then the next argument you would want to supply with is the seek method. So there's 3 seek methods that Python uses, which is 0 would indicate offsetting from or moving from the top of the file down. 1, I believe, is offsetting from your current position. So if you're already at the middle of the file, it'll move from the middle of the file down. But it could be any position, wherever the cursor stopped or is currently at. It would move from that position down. Or I guess you can go up or down. It doesn't matter. And then the third mode will move you from the bottom up. Okay. Now, when you include this script, there are constants set. So, for example, Noesis seek absolute will be 0 for mode 1. So we can use that to kind of abbreviate and get a more visual understanding of what we're doing. So, Noesis seek, yeah, Noesis, yeah. I'm not sure if it looks like, I forgot already. Yeah, that's right. Noesis seek underscore absolute. And that'll bring us to the file table. And the file table is really simple. It's just 4 long integer values. So that's integer is 32 bits. So that's 1, 2, 3, 4. And then we have like another entry in the table. So it's just repeat, rinse and repeat. So entry 1, entry 2, entry 3, so forth, so forth. So pretty simple. So we have to just clean this up because the difference between QuickBMS and Python. So we're gonna get rid of this thing and the file type, I guess. I guess this is like the class, and then the other thing is like the file type. I'm not really sure actually. So this other thing here, hash and type, they're glowing blue because they're probably a reserved keyword, so we need to modify them. So I'm just going to say hash ID and type ID so that they don't glow anymore. And then we can just go equals f.read u int. Okay, so that's coming from the Noesis Bitstream class. Read u int will be reading a unsigned integer. Okay, so that's again 32 bits. Okay, so I'm going to put that there, there, and there. Now he tries to make up a file name. I'm going to do my own. Just because I didn't really understand his expression there. He's using things that are specific to QuickBMS, I think, and I don't quite understand it. So mine's going to be a little bit simple, but we're going to say, we're going to take the hash ID and convert it to a hex value. Hex is blue, so it's a keyword, so it's native to Python. Yeah, Python, yeah. And we're going to, I guess, convert that into a string, I guess. So str, we'll convert that to a string. And then we'll add this to the extension. So file plus, and then the extension is apparently variable. So it depends on the type ID. So we're going to want to go string again, and then the type ID. So should be the hex, should be the hash ID as a hex decimal value dot file with whatever the type ID was. Okay, and then we can also do a debug print, so that would be just print, and then in brackets we just go like file name. Okay, now this one here, log, this is for QuickBMS to save the file. This will be replaced with wrapy dot export archive file. The next I is for a for loop for QuickBMS, so we can just get rid of that. Okay, so this is all good. Oh, you know what? I forgot. We have to get the file count to plug into this. 152 is constant. We want to change it to a red value. So we're going to go file count, equals, oh, I actually have to seek to a position first, so this is going to be 5C. That location is right here. That's 72 on this one. Okay. This is going to be reading another integer value. And then I have to change the for loop here because it's not quite right. So for I in range, and the range will be from 0 to the file count. And then there's our loop. And we don't put any braces or any next or anything like that. Just put the indentation in correctly, and it should just loop until it hits the end of the range. Excuse me. Just double check what else I'm forgetting. Oh, okay. I forgot. I have to seek to the position because I have to read the data. So once we read this in the file table, we're going to move to the actual file itself in the archive. So we're going to do another fseek. And that's going to be to the offset. And that's going to be Noesis seek absolute. Okay. And then we can run this thing, which would be the file name, and then an array of bytes. So we can just use, actually, no, we have to actually use the Noesis Bitstream for that. So that would be read bytes. That's right. Replace that with read bytes. And then the file size is given to us with size. Okay, so put that in there. That should be correct. Okay, now once we're done reading this, we probably want to go back into the file table itself. So at the top of this thing, I'm going to put the address here. So if we use this as it is now, it'll just put us at the first entry every time. So we need to index and go to the next entry. So we're going to go plus in brackets I times 16. So I is the integer that's given to us by the index. So each time the loop completes, this will increment by 1. So when we begin the first loop, so the first file will be 0, right? So I will be 0 the first time, times 16 is 0, plus the base address is the first address in the table. And then when we go from there, it'll just keep incrementing or indexing. So each one of the entries is 16 bytes, and it'll just keep kind of going down in an index kind of fashion. So that'll work. This thing, I'll just replace this with a whatchamacallit, a kind of constant value. So I'll say table address equals. I'll just plug that in there. If we ever do figure out how to calculate it, then we can put the formula in there, and then it'll naturally just plug into there through the variable. Now I think that's all good. Yeah, because I'm going to save this now, and we're going to try and run it. There might be some issues because I'm having some issues with the indentation a lot. It's getting kind of annoying. Sometimes it works and sometimes it doesn't. I don't know what's going on. Yeah, so when I do a nuke space, it works. But if I go tab, it just kills it. I don't know what's going on. Okay, let's go into Noesis. And if you get some like errors or something like that, it usually pertains to syntax. Like for example, if I go tab backspace and I save and I reload that, oops, no, reload. Yeah, because it's invalid because this is wrong. So you want to get through all your like syntax things. I've had enough practice that it usually sometimes works now without any errors. So that's cool. So close that, reopen it. No errors. Not too bad. So if I click on this, double click on this, it should bring me into the export menu. If I click export, it should print all the file names and then complete correctly. Now the only thing that I don't understand is this first thing. I didn't print it. This is from Noesis. It says output extension has set output file type to unknown. I didn't really set it, but it thinks it's unknown. I don't know if that's important or not, but the files did extract, so you can see them. They're in here. Okay. Now there's one thing I didn't add in here, which is a logic statement or a exception catch to catch any like invalid data. For example, if the address tries to go past the file itself, you can't do that, and you get an error. So that's actually what I encountered on the other one here. We'll see if that works or not. Yeah, it throws an error. So you may want to put some extra like exception handling or like logic checking in here. Like for example, if I get rid of this one, we can replace this with an if statement. So we go if the offset plus the size is, I guess we have to go less than the overall file size, then you may do this. Else print, I guess we just put like error, I guess, address out of range. Cool. Just double check. Is this screwed up or not? Yeah. Oh yeah, it's super screwed up. I don't know why it keeps doing this. Tools, reload plugin. Export. Oh, that's right. I silenced the other print, so that's why that's the only print there. But yeah, so that works now, but it skips one file. Oops, I need to click on that. It's supposed to be 72, and I got 71, so you can do that whatever way you want. But for some reason, one of the file addresses just goes like crazy. I don't know what's going on. Anyway, yeah, whatever. That's my interpretation of converting Crox's quick BMS script into Python for Noesis. Not sure how effective that would be because I'm not really experienced with what's more efficient or whatever, but it seems to work. So I mean, there's that. Anyway, take care, guys. Good luck with your projects, and have fun, I guess. Later, guys.